Welcome to Haxby Shed. Now I'm saying that because I'm not sure if this is the end of part 1 or the beginning of part 2. I won't know till I edit it up. But in case it's the beginning of part 2, I'll just say the project here is to make another X-axis table nut for my Harrison milling machine. So I've ordered up the bronze, £33 for 100 millimeters length, 31.8 diameter, that's nominal, and I got it from Rapid Metals. And this morning they phoned me to say, we haven't got 100 millimeters length. I asked for 100 millimeters to give me plenty to put in the chuck to work on, but we have got an 80 and a 50 for the same price. And I said, yes, okay, go ahead, send that. Hopefully I'll have enough material to work with. And then I've also ordered and received from Simply Bearings these two 7005s, their budget £14 each. Now I figure they're not going to be worn out in my time, so budget will be okay, but take a look on the internet. You can pay a small fortune for these 7005s, particularly if you go for high precision. And these bearings go either side of this nut into this housing here. Now normally at this point, anytime I mention money, I'll typically say, well, it's so much in US dollars and so much in euros. But what I've done this time is to make a chart which shows you what the current exchange rates are for my top 5 viewing countries. Now you might be surprised to see that India is always in my top 5. At the moment it's just below Canada, but if I looked at lifetime, because this is just the last 4 weeks, if I looked at lifetime, India would probably be in second place. And here's the percentage of audience. Now YouTube doesn't have a country called Europe. If I added up all the component countries of Europe, I suppose they would possibly come third, something like that. But if you're really wondering, well, there's about 1.16 euros to the pound at the moment. Yeah, okay, so the next thing we need to do is to check what the lead screw thread actually is. We know it's 5mm pitch. Well, that's a metric pitch, isn't it? But is the thread cut to metric standard or is it cut to imperial standard, which really means it's an Acme. Is the thread angle 29 degrees inclusive or is it 30 degrees inclusive? My suspicion is that Harrison used a normal 5 TPI Acme cutting tool to cut this 5mm pitch thread, because if you figure it out, I think that 5 TPI is 5.08 millimeters. So, you know, they may have cut a special tool, but my instinct is they would have used a normal imperial 29 degree inclusive tool. We will see. But what I've done to try and test this is I've cut 2 little plastic triangles, one there and one over there. Now the I stands for imperial and the M stands for metric. I cut them out of this bit of plastic, and I've got a couple of gauges here. This is a 29 degree gauge, this is a 30 degree gauge. We need to figure out, you know, which of these they've used. I think it's going to be 29 degrees, and I can actually tell you it is because I've measured it on the screw. Now, it's a bit tricky trying to get the thread root distance right for this. So there's 5 and there's 5. That would be 5 mil, that would be 5 TPI. I would much prefer to use an Acme thread gauge, but they're about £35 or more, and I'm not going to buy one just for this one job. It's not worth it. This is the 30 degree. Now you probably can't tell from there, but there is a little bit of rock on it. But if we try the 29, and I've looked at it with an eyeglass, I think this is nearer. So we're going to go with a 29 degree. Now, saying that it's 29 degrees is the easy bit. Next thing is to grind a tool up, and actually first to decide how I'm going to hold it. Well, I'm going to use this boring bar, which is 3/8 diameter, which is 9.44 millimeters. At least that's what this measures. Now we're going to be cutting a thread for a major diameter of 19 millimeters. The core, the root, has got to be about 19 minus 5, which is 14. The depth is 2.5 millimeters, near enough. So the tool has to stick out 2.5 millimeters out of the bar, and if you work that backwards from 14, gets you to, what does that get you to? 11.5, I think, would be the maximum size of bar that we could use. Well, you don't really get 11.5 millimeter bars, do you? So it would be a 10, and I haven't got a 10, but I've got a 9.438. So this is what we're going to try. Whether it's going to be rigid enough, I don't know. Anyway, we're going to grind up a tool for it. It takes 3/16 diameter high-speed steel. I've got to grind the tool at half the angle, which is 14.5. And so to help me, I've used this protractor, set the angle, clamped it here, and that operates then as a guide, look, with my bit of tool steel here. Now I can't set this to exactly 14.5 because there's a little bit of wiggle in this and a little bit of error. I don't know that this rest is absolutely 90 to the wheel. But with a bit of trial and error, I think I've got at least this far with it. And that should be a 29 degree inclusive knife on there. It's taken quite a bit of time to get to this. Let's check it in the gauge. Let me try and show you this first without the light on. I don't think that's too bad. Now when I put the light on, I'll probably blind you, but we'll see. Okay, you can see a little bit of light either side of it, but I haven't yet finished grinding it. But it's not far off, is it? Well, I think that's done. Been quite tricky. A little bit of side rake, a little bit of top rake, a little bit of slope angle on the top rake because it'll be cutting this way, like this. Now it might just be not quite wide enough, but if need be, I can put a little bit on to move it across, so do a cut like that and then do a cut slightly to the left. Probably tricky to see that, but you get the idea. Now before I cut off the excess here, we need to check the distance between there and the front of the tool must be less than 14 because that's the minor diameter of the thread, and it's about 13.1. And this bit, the cutting edge, needs to stick out by at least 2.5, and it's about 3.75. So I think we're pretty safe to chop it off by there. I'll get probably the air cutting off tool to just chop that through. Now I can still adjust it a little bit. I've still got some freedom, even if I need to adjust it slightly. Right, we're done. There's probably 2.5 hours work in that. I'm going to put this table motor and gearbox back on before it gets knocked off. It's only balanced on the motor like that, look, so it's just an accident waiting to happen. I've cleaned up these faces here, across here. I'm not going to make a gasket, I'm just going to use Hylamar. This assembly is heavy, but there's two dowels, one there and one there. If I can get those in and keep it pushed over, it should be manageable, and then get a screw in. If the table doesn't run away from me. There it is. That's it. Because there's no lead screw in the table, of course, it can easily do that. I've got some noisy relatives playing out there, making a bit of noise. Disturbing the peace at Haxby Shed. So it's nicely clamped up on these 3 screws here. That's just to show you the insides really. This gearbox has gear wheels here on the end, and I think there's 8 separate gears to make up 8 combinations of ratios. And overall, the ratio between the lowest gear and the highest gear is about 14.3 to 1, which is a bit fiddly here, but it's very useful because if you were driving a rotary table from the lead screw, it would be very handy to have this range of gears. So that's one of the 4 jobs ticked off then. Part 1 of this mini-series went out this morning and I'd like to respond to some of the comments. Now, all the comments have been helpful and have really set me thinking. So first off, let's look at these bearings. Now, I think they are what you call annular contact bearings. So they're designed to have side load as well as radial load. This one is nice and snug, let's say. There's no free play on that. But this one there is. And in fact, I was trying to tap this in and this outer ring just kind of popped off. Now if I bring it forward, you'll see how this bearing is constructed. Okay, so it's thinner at this side and thicker at this side. Now what confused me was the fact that when I look at the literature, it says that the markings should be on this side, like this one has, but this one doesn't. So maybe it was a different manufacturer, I don't know. But also when I look at these replacement bearings that I bought, which are a no-name kind of cheapo, well, KG, sorry KG if it's a good brand, there's very little movement on them. It's like this one. So is this bearing kaput? I don't know. I think these are on the right way around. They both measure about 3.4 millimeters here, near enough, and about 2 millimeters here. So I think they are both on the right way, but this one just has so much slop in it. Now I've kept these in the packet in case I decide to send them back, if I decide to stick with these. I've just tapped that outer race back on, pending a decision about which bearings to use. But there's a question, and that is, how would I get this bearing off this? Now I can use this piston from a brake caliper, and it nicely sits like that. How does it sit? That way. So it's a perfect thing for pressing this outer race off, but we know what's going to happen. It's just going to pop off. So how do I get the inner race off? Well, I'd have to use a die grinder, or I'd have to drill through here a couple of holes and knock it from this side. It's not the easiest thing to do, so probably if I can use this still, that's what I should be doing. And then I just send those bearings back. They were about £28. I've probably already said that, haven't I? In a previous video clip. So next, let's turn our minds to this nut. Well, question was, could I bore it out and press in a new inner and machine it out? I don't think so. I don't think there's enough room because the thread major diameter comes to about here. Well, it doesn't give me very much. I mean, maybe I could. And what would you do? Silver solder it? Don't know. So I'm not saying it's impossible. I'm just saying it isn't that easy to do. The way this is set up, it's almost as if that they intended all along to have some kind of backlash adjustment. You know, that it just lends itself to that. So I think we should take the opportunity to incorporate some kind of backlash adjustment. Now, if I knock this out, we can have a look at it. I can guarantee, I can tell you 100%, it's all solid. There's no sliding sleeve or anything on this nut. Now, somebody suggested, and I like the idea, of cutting this down here and then using the two halves, and then you could compress them together to take out the backlash using this ring. This isn't quite long enough for that. We'd lose quite a bit of material cutting it. You know, could use a thin slitting saw, I suppose. But this and this would have to be locked together somehow, and maybe you'd make some sliding pins like these between the two halves of the nut. Because I think if this part could spin independently, I mean, even though it is pressed into here, it's not impossible, because it's only a light press fit, that somehow this could spin and act as a lock nut against this. I don't know exactly how, I can't tell you how, but I know it would be possible. And that would be a problem, I think. Somebody asked if I could use a spindexer to index these. Well, great idea, but unfortunately there's 48, which I think means 7.5 degrees per. And the spindexer doesn't do half degrees. So it will have to be done with a dividing head if I cut these. They're 90-degree splines, so I can use an end mill tilted over at 45 degrees, I think. If I get this lined up correctly, that in itself isn't easy. And cut this way, out, index, cut, out, index in one pass should be possible. This nut, by the way, you might not be able to see it, but there's a step there, a little step. So it's 32 millimeters here, and it's 31.8 here. So I think this dimension is 1¼ inches. So it's just necked, narrowed a little bit there. You know, looking at this nut on the thread, I mean, it moves this way, front and back, that way, but it also rocks like crazy. It's pretty sloppy, and I think it would be better to make a new one. I need to change the gears to get 5 TPI, which is there, and it needs to be these red gears. It says change wheels for line 1, 50, 80, 80. I'm just trying to remember the order. I think it's that to that, then that to that. Makes sense? Do it approximately first. So that to that. That's too tight, but never mind. Then this banjo plate up here to that. And then adjust accordingly. If anybody has an involute cutter, 14 DP, 14.5 pressure angle, number 2, someday I'd like to cut a new 63 tooth gear. I've got this one in Delrin and it works, but it would be nice to have one in steel. Ideally, for a 1-inch arbor. I've also got a 27mm arbor. I can get a set from China for £80, but the one I'm talking about is for a 22mm arbor, and I don't have a 22mm arbor. So, you know, if you've got one kicking about in the bottom of your drawer and you want to sell it to me for a sensible price, let me know. Oh, and it's not blunt as well, that's the other thing. So you can see I've put this assembly back together minus the nut. And I think those bearings are fine, the original bearings. When I clamp this up with a bit of preload, there's no slop on it whatsoever. They run smoothly. So I think that's fine. I drilled that out with a 14mm, but measuring the lead screw, I realise it's not enough clearance for the minor diameter. So I'm now going to quickly drill it out with 9/16, which is 14.28mm, and that'll just give me that extra 1/3 of a millimetre. Probably the next thing to do actually to check that I've got that pitch set up correctly. But you can see how it flies round here. I've got the tool in upside down and the lathe going in reverse. I'm just going to scratch on the outside of this bar. It's still quite irregular, but I'm hoping it's enough for me to see that it's a 5mm pitch. I've just made a cut there at 32 exactly, so I can just get it out of this bar. Now, it comes out towards us at this side, and I can just scratch this surface, I think, with the threading tool without going down below 32mm. Might be difficult for you to read, but I read that as 5mm pitch. I've got this sized at 32, and I've got that cut. So the next thing to do is to part this off to length, so I can thread right through it. That was for the gentleman who asked me to show more machining. So the question is, how long do I make this thing? Now this is 30.45 across here. And then each of these cups has a recess of 2.5 millimeters. Now I think to have enough travel for a kind of backlash system, we probably need a millimeter of control, a millimeter of adjustment. So if we take 30.45 plus 2.5 plus 2.5 for these recesses here, plus a millimeter. So if, what's that? 2.5 plus 2.5 is 5 plus 1 is 6. 36.45 I think is the magic number for the length of this, from that face to that face. And then over this, which is that, sits this cup, which is that. And then on the end we have this big locking ring, which is that. So the logic is that we have a split in this, two halves, so we machine it all the way through, we thread it all the way through first, then we cut it in half, maybe put a couple of pins in, don't know yet, so that this, say this end had the splines on it, we don't want this end to be free spinning, so we might put a couple of pegs through or something, I don't know what yet, and then it will stick out about a millimetre more, so there'll be a gap of about a millimetre there, and then as it wears, you tighten that ring, moves this cut forward, presses on this, presses on the back half of the nut and takes up the backlash. That's the plan. The calculated measurement of 36.45 mil compares with 35.49 for the length of the old nut, so we know we're in the right zone.